Welcome to Sleepy Crimes. I am Anna, your host. Tonight, we drift into the shadows of the Permian Extinction. We journey back, far beyond the memory of man, to a time when the world was one, a singular landmass huddled amidst a sea of infinite blue. Imagine, if you will, the weight of 252 million years pressing softly against your eyelids. We are traveling to the twilight of Pangaea. Before the Great Dying, before the fire and the ash, there was a quiet world of strange beauty. It was a time of equilibrium, where the ancestors of mammals and reptiles shared a sun that felt eternal. Close your eyes and breathe in the ancient air. It is thick, warm, and carries the scent of pine and damp earth. There are no cities here, no roads, only the rhythmic pulse of a planet in its prime. It is a world of incredible scale, where the land stretches into the horizon without end, and the sky is a vast, unblemished canopy of deep indigo. The supercontinent of Pangaea stretches from pole to pole, a vast tapestry of terracotta deserts and emerald forests. At its heart, the land is a furnace of dry heat, where the wind whistles through canyons that have never known a raindrop. But at the edges, where the great ocean Panthalassa kisses the shore, the world is lush. Visualize the vast, sweeping plains. The soil is rich with minerals, painted in shades of ochre and deep sienna. There are no flowers yet, no bright petals to catch the eye or scent the wind. Instead, there is a sea of green that seems to swallow the light. Towering tree ferns and ancient conifers stand like silent sentinels under a sky that is a deeper shade of blue than any we know today. The silence is profound. It is the silence of a world that is whole, where every mountain range is connected, and every creature can walk from the frozen south to the sweltering north without ever touching a wave. Moving through this landscape are the masters of the Permian. These are not the dinosaurs of our common imagination, but their precursors, the synapsids. Imagine a creature like the gorgonopsid, a predator with long saber teeth, prowling with a heavy, deliberate gait through the undergrowth. Its breath is steady, a low hum in the stillness. Nearby, the herbivorous Scutosaurus grazes, its bony, armor-plated skin catching the golden light of a setting sun. These animals move with a slow, heavy grace, their lives dictated by the warmth of the earth and the cycle of the seasons. There is a sense of permanence here, a feeling that this era would last forever. The evolutionary trees are branching out, experimenting with life in ways that seem alien and yet familiar. We see the beginnings of our own lineage in the structure of their skulls and the shape of their teeth. They are the rulers of a golden age, unaware that the ground beneath them is a ticking clock. Turn your mind now to the edge of the world, where the land ends and the Panthallassic Ocean begins. This is a single, global sea, an immense body of water that wraps around the planet like a cooling shroud. The waves are slow and rhythmic, breaking against rocky headlands with a sound like a long, drawn-out sigh. In the shallows, coral reefs made of ancient rugose and tabulate colonies teem with life. Trilobites, those armored wanderers of the seafloor, scuttle through the silt, their many-faceted eyes reflecting the flickering sunlight that filters down through the brine. Ammonites drift in the currents, their spiraled shells bobbing like prehistoric lanterns. The water is oxygen-rich, teeming with vitality. It is a cradle of life, vast and seemingly invincible. The salt spray hangs in the air, a fine mist that settles on the ferns of the coast, a reminder of the delicate balance between the land and the deep blue void. As the sun dips below the horizon of Pangaea, the sky turns into a bruise of purple and gold. The heat of the day lingers in the stones, radiating upward into the cooling twilight. The stars emerge, unfamiliar constellations that have long since shifted and vanished from our modern charts. There is a deep, abiding peace in this Permian night. It is the peace of a world at its peak, a moment of geological perfection. We linger here, in this final era of the Paleozoic, appreciating the complexity of an ecosystem that had flourished for nearly 50 million years. Every rustle of a leaf, every distant call of a primitive amphibian in the marshes is a testament to the resilience of life. We do not yet see the cracks forming in the Earth's crust. We do not yet feel the heat rising from the deep mantle or the sulfur beginning to stir. For now, we simply exist in the twilight, drifting through the shadows of a world that was once our home. Let the stillness of Pangaea settle over you. Feel the slow rotation of the Earth as it carries this massive supercontinent through the dark of space. The air you breathe in your mind is the air of a paradise, a world of one land and one sea, standing at the precipice of a transformation so absolute it will nearly extinguish the light of life itself. But that is for later. For now, the wind is gentle. The conifers whisper to the ferns. The predators sleep in the tall grass, and the prey huddles in the warmth of the burrows. The world is at rest. It is a moment of perfect, fragile grace before the shadows begin to lengthen and the ancient order begins to crumble. As you drift deeper into relaxation, remember the textures of this world. The red sand, the green ferns, the salt of the sea, and let them carry you toward a deep and restorative sleep. The story of the twilight is only just beginning, and you are safe within its quiet embrace. The air over the supercontinent of Pangaea begins to change, not with a sudden roar, but with a subtle, heavy stillness. Imagine standing on a vast, grassy plain 252 million years ago. The wind, once crisp and life-giving, starts to lose its edge. It carries a new weight, a stifling quality that clings to the skin like a damp shroud. This is the onset of the fever. It begins in the atmosphere, a chemical shift so quiet that the great reptiles and early ancestors of mammals go about their days unaware that the very breath of the planet is being altered. The carbon dioxide levels, once stable, begin to climb from 400 parts per million to levels 4 or 5 times higher. It is a slow, invisible thickening of the sky, trapping the sun's warmth and refusing to let it go. The horizon takes on a hazy, copper tint as the first signs of a global sickness take hold. Beneath the surface of the northern lands, in the region we now call Siberia, the earth is beginning to bleed. This is not the familiar eruption of a single mountain peak, but a tearing of the crust itself. Fissures stretching for thousands of miles open like jagged wounds. From these cracks, molten basalt flows out in slow, unstoppable waves, covering an area the size of a continent in liquid fire. But it is not just the lava that causes the fever. As this white-hot stone pushes upward through the deep layers of the earth, it encounters ancient, massive beds of coal and organic matter. It cooks them. The resulting gases, methane and carbon dioxide, are exhaled into the atmosphere in quantities so vast they are difficult to comprehend. Billions upon billions of tons of greenhouse gases rise into the sky, creating a thermal blanket that will eventually raise the global temperature by more than 10 degrees Celsius. In the fossil record, this period appears as a series of missing pages in a long, dusty book. Paleontologists look at the stone and see a ledger of disappearance. Before the Great Collapse, the forests of Pangaea were lush and diverse. Giant seed ferns with leaves the size of umbrellas, known as Glossopteris, once carpeted the southern lands. But as the fever takes hold, these hardy plants begin to falter. The fossils show a strange, haunting trend. The leaves become smaller, their veins more tightly packed as they struggle to conserve water in the rising heat. Then, they simply vanish from the layers of rock. In the tropical heart of the continent, the great Gigantopterous forests, with their intricate, lace-like foliage, begin to brown and wither. The fossilized pollen tells a story of sterility. The plants are no longer reproducing, their delicate cycles broken by the relentless, unseasonal warmth that never recedes. As the land heats up, the oceans begin to lose their breath. The sea is the great regulator of the world, but even its vast waters cannot ignore the rising mercury. Imagine the surface of the Panthalassic Ocean, a single, endless sea that wraps around the world. The water at the equator begins to warm until it reaches temperatures of 40 degrees Celsius, over 100 degrees Fahrenheit. It is the temperature of a hot bath, too warm to hold the oxygen that marine life depends on. In the fossilized reefs of South China, we see the results. The microscopic organisms that build the seafloor, the foraminifera, begin to disappear from the record, leaving behind a physical gap in the stone. The chert layers, formed from the silica skeletons of countless tiny beings, simply stop. The ocean floor becomes a quiet, stagnant place, as the currents that once brought oxygen to the depths begin to slow and fail. There is a phenomenon scientists call the Lilliput effect, a name borrowed from the tailies of tiny people. In the layers of rock preceding the final catastrophe, we see life itself beginning to shrink. The shells of brachiopods and the bodies of burrowing creatures become smaller with each passing generation. It is as if the animals are trying to diminish themselves, to require less food and less oxygen as the environment becomes increasingly hostile. This dwarfing of the biosphere is a desperate, evolutionary response to the fever. The giants of the Permian, the heavy-set herbivores and the apex predators with their sail-backed spines, find their world closing in. The vibrant, noisy ecosystems of the past are replaced by a profound, oppressive silence. The air is thin, the water is warm, and the land is parched. The first signs of the fever have passed. The planet is now moving into a state of true delirium. We are witnessing the slow-motion dismantling of a world. Every breath taken by a creature on Pangaea is now a struggle against the rising tide of carbon and the dwindling supply of oxygen. The sulfur dioxide released by the northern eruptions begins to fall back to Earth as acid rain, scaring the leaves of the surviving trees and poisoning the freshwater streams. The very chemistry of the rain has changed, turning the life-giving water into a corrosive mist. As we look at these ancient disturbances, we see that the Great Dying was not a single, sharp blow, but a long, agonizing period of decline. The fever has taken hold of every mountain, every valley, and every wave. The Earth is no longer the stable home it once was. It has become a furnace, preparing for the final, devastating pulse that will nearly wipe the slate of life clean. The ground beneath the northern reaches of Pangaea is no longer silent. For millions of years, the Earth here was a quiet tapestry of vast coniferous forests and winding river systems, but deep within the mantle, a monstrous force has been gathering. Imagine a column of searing heat, a plume of molten rock rising from the very boundary of the planet's core. It has traveled thousands of miles upward, pressing against the underside of the continental crust like a slow, heavy pulse. The land begins to bulge, stretching the ancient stone until it can no longer hold. 252 million years ago, the first cracks appear. They are not the violent, singular explosions of a mountain top, but long, jagged fissures that tear across the landscape for hundreds of miles. Through these wounds, the Earth begins to bleed. This is the birth of the Siberian Traps, a volcanic event so massive that it defies our modern understanding of disaster. The lava does not simply flow, it floods. It is a basaltic river, thin enough to run like liquid iron but heavy enough to drown everything in its path. Imagine standing on a distant ridge, watching a wall of fire advancing at the pace of a slow walk. It consumes the ferns, the towering trees, and the slow-moving reptiles of the Permian lowlands, encasing them forever in a tomb of black glass. As the layers of lava cool, they form massive, step-like structures, a landscape of dark stone staircases that will eventually cover nearly 3 million square miles. That is an area the size of the entire United States, buried under a sea of molten rock. In some places, these flows stack upon one another until they are 4 kilometers deep. The sheer volume of this material, 4 million cubic kilometers, is enough to wrap the entire globe in a layer of basalt 20 feet thick. The weight of it presses down on the world, a physical manifestation of an ending. But the true horror of the Siberian traps is not what happens on the surface. It is the invisible chemistry happening in the dark. As the magma rises through the crust, it does not encounter simple rock. It hijacks a subterranean treasure trove of carbon. Beneath Siberia lie immense deposits of coal and oil, the remains of even older forests from the Carboniferous period. When the white-hot magma touches these coal seams, it does not just melt them. It ignites a subterranean furnace of unimaginable proportions. The earth becomes a giant oven, baking these ancient fossil fuels and releasing billions of tons of methane and carbon dioxide directly into the atmosphere. You can almost hear the low, subterranean roar of the earth gasping as it vents these toxins. It is a slow-motion detonation of a chemical bomb, a silent killer that begins to rewrite the very composition of the air that every living thing must breathe. The sky, once a clear and vibrant blue, begins to transform into a bruised, sickly yellow. The sun is no longer a bright disk, but a dim, orange ghost flickering behind a thick veil of volcanic ash and sulfur dioxide. When it rains, the water is no longer life-giving. It is a diluted acid that stings the leaves of the surviving trees and dissolves the delicate shells of creatures in the shallows. The smell of sulfur, the sharp, acrid scent of rot and burnt matches, becomes the permanent perfume of the world. This is the stage of the extinction where the temperature begins its relentless climb. The greenhouse gases trapped in the atmosphere act like a heavy woolen blanket thrown over a feverish patient. In the equatorial regions, the ocean waters begin to warm until they reach temperatures of over 104 degrees Fahrenheit. It is a heat that offers no relief, a stagnant, humid pressure that drains the energy from every lung and every gill. Take a moment to listen to the silence that follows. In the wake of the lava, the forests are gone. The insects, once a constant hum in the Permian air, have fallen quiet. This event marks the only time in the history of the Earth that insects suffered a mass extinction. The vibrant life of the great dying is being systematically dismantled, piece by piece, by a planet that has turned against itself. We see the evidence of this struggle in the rocks today, the jagged layers of ash, the sudden disappearance of complex pollen, and the haunting presence of charcoal. It is a somber reflection on how fragile the balance of life truly is. As the gates of hell remain open for 2 million years, the world enters a state of waiting. The old world is dead, but the new world has not yet found its breath. We are caught in the transition, drifting through the smoke of a world that is burning itself away to the bone. Consider the scale of this patience. The earth does not rush its tragedies. It took hundreds of thousands of years for the carbon to reach its peak, for the oceans to lose their oxygen, and for the 96% of marine species to finally vanish. Each century was a slow tightening of the noose. As you rest now, safe in the stillness of the present, let the magnitude of this ancient history settle over you like a heavy, warm blanket. The fires of Siberia are long cold, their black basalt now covered by the tundra and the taiga. The fury has passed, leaving only the quiet testimony of the stones. Breathe in the cool, clean air of your own time. The world is stable. The shadows are long, and the story of the Great Fire is a distant echo. The heat of the Permian is gone, replaced by the soft, comforting dark of your room. Rest your mind. Let the details of the basalt and the steam drift away. You are safe in the silence. The atmosphere was a thick, bronze veil, but the true weight of the tragedy began to settle beneath the waves of the Panthalassic Ocean. Imagine standing on a shore that no longer exists, looking out at an expanse of water so vast it stretches from pole to pole. At first, the sea appears unchanged. The rhythmic pulse of the tides remains, and the moonlight still silver plates the crests of the waves. But if you were to reach down and touch the water, you would feel a subtle, unsettling warmth. It is not the refreshing tepidness of a summer afternoon. It is a fever. The great heat generated by the Siberian traps has begun its slow, relentless conduction into the depths. This is a story of a world losing its breath, where the very element that once nurtured life becomes the medium of its undoing. The water is no longer a cradle. It is becoming a tomb, and the shadows moving within it are the first signs of a grace falling into silence. For hundreds of thousands of years, the ocean had functioned like a massive, churning heart. Cold, oxygen-rich water from the polar regions would sink, flowing along the deep seafloor toward the equator, while warm surface waters moved back to the poles. This delicate conveyor belt ensured that even the deepest trenches received the oxygen necessary for life. But as the planet warmed by nearly 10 degrees Celsius, this heartbeat began to falter. Warm water is lighter and less dense. It floats stubbornly at the surface, refusing to sink. The vertical mixing that once refreshed the abyss simply stopped. The ocean became a series of stagnant, unmoving layers, like a cup of tea left to sit until a film forms on the top. Without the cooling influence of the poles, the depths began to bake in their own stillness. We often think of extinction as a sudden flash, a strike from the heavens, but here, it was the absence of movement that brought the end. As the temperature of the water climbed, a cruel biological trap was set for the creatures of the Permian. There is a fundamental law of physics that dictates that warmer water can hold significantly less dissolved oxygen than cold water. At the same time, the metabolism of cold-blooded marine life, the trilobites, the brachiopods, and the early armor-plated fish, speeds up as their environment heats. They needed more fuel and more oxygen just to maintain their basic functions. But they were trapped in a sea that was providing less and less with every passing century. Imagine the slow-motion panic in the gills of a creature that has nowhere to go. To move faster is to burn more oxygen, which is already vanishing. To stay still is to slowly suffocate. The fossil record shows a desperate migration toward the poles, as species fled the suffocating heat of the tropics, only to find that the oxygen-deprived shadows had followed them there. There was no refuge left in the blue. The silence in the water deepened as the oxygen levels plummeted by nearly 80%. In the shallows, the vibrant coral reefs, built not by the corals we know today, but by strange, rugose and tabulate forms, began to bleach and crumble. The schools of ammonites, with their elegant coiled shells, found it harder to rise and fall through the water column. The sea was becoming acidic as it absorbed the massive quantities of carbon dioxide from the air, making it difficult for creatures to build their protective skeletons. You can almost hear the soft, ghostly rasp of shells thinning and dissolving in the darkening brine. On the seafloor, 40% of the environment became entirely anoxic, meaning there was no oxygen at all. The scavengers were the first to go. Without the crabs and the worms to clear the debris, the fallen bodies of the dead began to carpet the silt, undisturbed by the usual cycles of decay. The ocean was holding its breath, and the breath was not coming back. In this profound absence of oxygen, a new and ancient power began to rise from the sediment. Bacteria that thrive in toxic, oxygen-free environments, sulfur-reducing microbes, started to multiply in the billions. They exhaled hydrogen sulfide, a gas that smells of rotten eggs and is lethal to almost all complex life. The water column, once a clear and vibrant blue, began to turn a bruised, sickly purple or a deep, impenetrable black. This process, known as euxinia, transformed the world's oceans into a vast, poisonous vat. The shadows in the water were no longer the shapes of hunters or prey. They were clouds of toxic gas rising like smoke from the abyss. This gas did not stay in the water. It began to bubble up to the surface, escaping into the atmosphere to further poison the air and the land. The ocean had become a chemical weapon directed at the very life it had spent billions of years evolving. When we look at the rocks from this period today, we find them in the form of black shales, dark, oily layers of stone that are packed with organic matter that never rotted. These stones are the preserved remains of that suffocated world, a physical manifestation of a time when the water was too toxic for even the smallest bacteria of decay to do their work. It is a haunting thought to consider that 96% of all marine species perished in this long, slow drowning. The trilobites, who had survived for nearly 300 million years and weathered 2 previous mass extinctions, finally met a shadow they could not outrun. They left behind only their intricate, stony eyes to stare forever into the dark silt of a world that had forgotten how to breathe. As the last of the great currents stalled, the ocean became a mirror of the dying land, reflecting a planet that was quietly, patiently, turning off the lights. The great forests of the southern world did not vanish in a sudden flash of fire. Instead, they succumbed to a slow, suffocating heat that turned the very air into a heavy, stagnant poison. Before the end, the supercontinent of Gondwana was a place of deep, shadowed greens and vast, swampy mires. If you could have walked there, your feet would have sunk into the soft, waterlogged earth, moving through a landscape dominated by a single, remarkable tree. This was the Glossopteris, the tongue fern, whose leaves were shaped like long, elegant ribbons, tapering to a soft point. These giants rose 30 meters into the air, their trunks thick and sturdy, stretching 80 centimeters across. They were the architects of the world's first truly massive forest ecosystems, their broad leaves capturing the pale light of a sun that seemed, for millions of years, to be a permanent guardian of the green. As the climate began its agonizing shift, the rhythm of these forests faltered. For eons, the Glossopteris had been deciduous, dropping their heavy, tongue-shaped leaves in synchronized waves each autumn. Imagine the sound of those billions of leaves falling, a soft, dry rustle that covered the forest floor in a carpet of bronze and gold. But as the carbon dioxide levels climbed, driven by the distant, thundering eruptions in the north, the seasons themselves began to blur. The air became thick with the scent of sulfur and the metallic tang of acid rain. This rain did not bring life. It brought a slow, chemical wilting. The delicate, web-like veins within the leaves began to fail. The deep emerald hues faded, replaced by the sickly pallor of decay long before the winter had even arrived. In the height of the Permian summer, a terrible silence began to settle over the canopy. We often think of forests as noisy places, filled with the hum of early insects and the rustle of small, lizard-like creatures moving through the undergrowth. But as the plants died, the life they supported vanished with them. The great dragonflies, with wings as wide as a human arm, fell still. The beetles that had burrowed into the bark found the wood too dry, too toxic, or too depleted of nutrients. The canopy, once a vibrant roof of whispering leaves, became a skeletal frame of gray wood. You could have stood in the center of a grove that had stood for 1,000 years and heard nothing but the thin, whistling wind passing through dead branches. It was a world where the green had been forgotten, leaving only the stark, vertical lines of a dying timberland. Then came the physical collapse. As the roots of the Glossopteris lost their grip on the increasingly acidic and parched soil, the giants began to fall. They did not fall all at once, but in a staggered, heavy succession. A trunk would groan, its internal structure weakened by heat and lack of water, before finally surrendering to gravity. The crash of a 30-meter tree in a silent world is a sound of profound finality. One by one, the pillars of the Gondwanan world toppled, creating a chaotic graveyard of timber that stretched for thousands of miles. Across what is now Australia, Antarctica, and South America, the land was buried under its own dead weight. The logs lay in the mires, but the water that had once preserved them was now gone or turned to a caustic sludge, leaving the wood exposed to a new and hungry force. In the fossil record, Scientists see this moment as a dramatic and haunting transition, known as the fungal spike. As the plants and the forests perished, they left behind a staggering amount of organic matter, millions of tons of dead wood and rotting leaves. Into this void stepped the fungi. Specifically, a microscopic organism called reduviasporonites began to proliferate in numbers that are difficult to comprehend. These were wood-rotting specialists, disaster species that found their paradise in the global graveyard. In the rock layers from 252 million years ago, the pollen of trees virtually disappears, replaced entirely by the spores of these fungi. The world was no longer a garden. It was a massive, planet-wide compost heap. The air would have been thick not with the scent of pine or fern, but with the cloying, earthy smell of mold and damp decomposition. This was the era of the fungal shroud. The fungi worked with a relentless, quiet efficiency, breaking down the remains of the old world. While it was a time of absolute devastation for the trees, it was a period of frantic, morbid life for the scavengers of the soil. The fungal spike serves as a grim marker in the stone, a line in the earth that tells us exactly when the green world surrendered. It is a reminder that when the complex structures of life fail, the simplest organisms take the throne. The silent canopy was gone, and in its place was a landscape of soft, white filaments and blackening wood. A world waiting for a recovery that would not come for millions of years. For now, the land belonged to the rot, and the sun shone down on a world that had lost its ability to breathe. The fungal shroud was merely the veil over a much deeper, more silent transformation occurring within the heart of the world's waters. For thousands of years, the Panthalassic Ocean had been a vibrant cradle of life, covering 70% of the planet's surface in a rhythmic dance of currents and tides. But as the Siberian volcanoes continued their relentless outpour, the world began to grow unnaturally still. The wind, once a constant companion to the waves, seemed to lose its strength, suppressed by the heavy, humid heat that now blanketed the globe. Imagine standing on a shoreline where the ocean no longer roars. There is no white foam, no spray of salt against your skin. Instead, the water lies flat and heavy, like a sheet of dark glass reflecting a sun that has become a pale, hazy orb. The air is thick, clinging to your lungs with every breath, as the great engine of the planet begins to seize. Deep beneath that stagnant surface, the great ocean conveyor belt was failing. Traditionally, cold water from the poles would soak up oxygen from the atmosphere, sinking into the abyss to carry the breath of life to the seafloor. But in this era, 252 million years ago, the polar regions had warmed too much. The temperature of the sea surface rose by nearly 10 degrees Celsius, and the water became too light to sink. The deep current slowed, then stopped. Without the constant arrival of fresh oxygen, the depths of the ocean began to suffocate. It was a slow, invisible catastrophe. The creatures of the abyss, the scavengers and the filter feeders that had thrived in the darkness for eons, found themselves gasping. One by one, the lights of the deep went out, leaving the vast trenches and plains of the seafloor to the silence of the dead. In this newly created void, a different kind of life began to stir. With the oxygen gone, the ocean floor became the exclusive realm of anaerobic microbes. These were not the vibrant plants or animals we recognize, but primitive, sulfate-reducing bacteria that had waited in the shadows for millions of years. As the organic remains of the dying world drifted down into the dark, these microbes began to feed, thriving in the absence of air. They did not breathe oxygen. Instead, they processed the abundant sulfates in the water. As a byproduct of their metabolic feast, they began to exhale an invisible, potent substance known as hydrogen sulfide. This was the beginning of the end. A microscopic empire was rising from the silt, turning the very chemistry of the ocean into a toxic reservoir that would soon reach from the deepest trenches all the way to the sunlit shallows. As the concentration of hydrogen sulfide grew, the water itself began to take on a ghostly, unnatural hue. In the areas where sunlight could still penetrate the upper layers, green and purple sulfur bacteria began to bloom in massive, shimmering clouds. The ocean, once a deep and comforting blue, was transformed into a thick, poisonous soup of pinks and purples. It must have been a haunting sight, a world where the sea looked like a bruised sunset, beautiful but utterly lethal. This condition, which scientists call euxinia, turned the coastal reefs and the open seas into a trap. Any fish or marine reptile that wandered too deep into these colorful clouds would be paralyzed instantly. The toxicity was so profound that even the base of the food chain, the tiny plankton, began to vanish. The ocean was no longer a source of life. It had become a vast, brewing cauldron of death. Eventually, the ocean could no longer contain the poison it had brewed. The hydrogen sulfide began to bubble up, breaking the surface in a phenomenon known as the breath of death. This was not a sudden explosion, but a slow, persistent release of gas that drifted across the coastlines and seeped into the valleys. To any creature still clinging to life on land, the arrival of this gas would have been heralded by the overwhelming, cloying scent of rotten eggs. It was an invisible predator, heavier than the air, crawling along the ground and filling every crevice where life sought refuge. The hydrogen sulfide did not just poison the lungs, it actively sought out the sky. As it rose into the upper atmosphere, it began to react with the ozone layer, the planet's only shield against the sun. The very air was being stripped of its protection, leaving the world exposed to a different kind of fire. With the ozone layer weakened by the rising gases, the sun's ultraviolet radiation intensified, burning through the leaves of the remaining forests and mutating the spores of the surviving ferns. The Permian world was being attacked from below by the toxic breath of the sea and from above by the unfiltered rage of the stars. It was a perfect storm of chemical and celestial forces, leaving almost nowhere to hide. The silence that followed was total, a peace bought at the cost of 95% of all species. The great pulse of the planet had slowed to a near halt, leaving only the sound of the stagnant waves lapping against a desolate shore. The case rests now. Let the details fade. You are safe. Close your eyes, breathe deeply, and have a good night. Sleep well. Imagine the sky above the ancient supercontinent of Pangaea, once a vast and welcoming expanse of deep blue, dotted with soft, white drifting clouds. Now, as the era of the great dying reaches a fever pitch, that sky has begun to transform into something heavy, suffocating, and unrecognizable. For centuries, the volcanic fissures of the Siberian traps have been exhaling with a rhythmic, subterranean violence, their deep lungs pushing staggering amounts of sulfur dioxide into the upper reaches of the atmosphere. The air is thick with a bitter metallic tang that settles on the tongue like a copper coin. You can almost feel the weight of it pressing down on the scorched forests and the silent, dusty plains. The horizon is no longer clear. It is shrouded in a persistent, yellowish haze that filters the sunlight into a sickly, amber glow. This is the beginning of the acid sky, a period where the heavens themselves turned against the world below. High above the earth, a quiet and invisible alchemy is taking place. As the massive plumes of sulfur dioxide rise, they eventually collide with the drifting remnants of water vapor. In the cold, thin air of the upper atmosphere, these two substances embrace, reacting to form microscopic droplets of sulfuric acid. These tiny aerosols gather together, forming clouds that are heavy and dark, laden with a chemical burden that the world has never seen on such a global scale. These are not the rain clouds of a tropical paradise, but the heralds of a slow, corrosive storm. They drift across the northern hemisphere, carried by changing wind patterns that have been disrupted by the rising heat of the planet. There is a stillness in the air before the first drop falls, a heavy silence that feels as though the very atmosphere is holding its breath in anticipation of the destruction it is about to release. When the rain finally begins to fall, it does not provide the relief that the parched earth so desperately craves. Instead of the gentle, life-giving patter of a summer storm, there is a soft, persistent hissing. These droplets carry a level of acidity so extreme that scientists would later compare them to undiluted lemon juice or the sharpest vinegar. As the liquid touches the leaves of the remaining conifers and the delicate fronds of the ferns, the effect is immediate and devastating. You can almost hear the faint sizzle as the acid begins to eat through the protective, waxy coatings of the plants. The leaves do not just wither, they are disfigured, their cells collapsing under the chemical assault. In the forests that still stand, the needles of the spruce trees turn a brittle, rust-colored brown before falling away, leaving skeletal branches reaching up toward the yellowed clouds. This rain does not wash away the dust. It seals the fate of the greenery, ensuring that the primary source of food for the world's remaining creatures is slowly dissolved into nothingness. The devastation does not stop at the surface of the leaves. As the acidic water seeps into the ground, the very chemistry of the earth is being rewritten in a slow, agonizing process. In a healthy world, the soil is a complex reservoir of nutrients, holding onto the calcium, magnesium, and potassium that allow life to flourish. But the relentless downpour of sulfuric acid acts as a powerful solvent, leaching these essential minerals from the dirt and carrying them away. The soil becomes toxic and sour. Scientists studying rock samples from the Dolomite Mountains in Italy would millions of years later find the chemical traces of this period, discovering an abundance of vanillin preserved in the layers. Under normal conditions, this organic compound would have oxidized, but the conditions were so incredibly acidic that the natural processes of decay were halted. The ground itself had become a preservative of its own destruction, a silent witness to a time when the earth was too bitter to even rot properly. With the forests dying and the soil losing its structure, the continental landscapes begin to crumble. Without the intricate networks of roots to hold the earth together, the hillsides become unstable. The rain, now a constant and corrosive presence, washes over the bare ground, carving deep, jagged gullies into the face of the land. This is the era of enhanced chemical weathering, where the very bones of the continent are being worn down by the atmosphere. Great rivers of thick, acidic mud begin to flow, carrying the remains of the topsoil and the dissolved minerals down toward the coastlines. The landscapes that were once vibrant and green are stripped bare, leaving behind a scarred and desolate world of gray stone and orange silt. This runoff does not just disappear. It carries its toxic burden into the oceans, further poisoning the waters and creating a cycle of death that connects the tallest peaks to the deepest seafloors. As you listen to the steady, rhythmic sound of the rain outside your own window tonight, try to imagine a world where every drop was a threat. The Permian Extinction was not just a single event of fire and ash. It was a long, slow accumulation of environmental stresses that wore the world down to its breaking point. The sky, which should have been a source of protection and life, became a primary weapon of the planet's transformation. The acid rain fell in pulses, sometimes lasting for years at a time, echoing the bursts of volcanic activity from the distant Siberian plains. Each pulse was a hammer blow to the resilience of the biosphere, stripping away the ability of plants to grow and the soil to support them. In the silence of this ancient world, the only sound was the constant, soft hiss of the acid sky, a sound that signaled the end of one era and the long, painful wait for the next. The beauty of the earth was being dissolved, one drop at a time, into the shadows of history. Imagine the world as a clock, winding down until its gears finally seize. We have arrived at the very apex of the vanishing, a period that history remembers as the Great Dying. The atmosphere had become a heavy, humid shroud, thick with the heat of a planet that could no longer breathe. The vibrant, bustling world of the Permian was beginning to fray at every edge, its colors fading into the monochrome of ash and dust. In this chapter, we witness the peak of the crisis. Not a single explosive moment, but a grinding, relentless erasure of life that stretched across thousands of years. The rhythm of the seasons had been replaced by a static, eternal summer that grew more punishing with every passing century. The earth was a furnace, and the sea was a tomb. Beneath the surface of the Panthalassic Ocean, the devastation was nearly total. For hundreds of millions of years, the seafloor had been a garden of intricate stone cathedrals, built by the rugose and tabulate corals. These colonial architects, who had survived countless shifts in the world's tides, now faced an enemy they could not outbuild. The water was turning sour. As the concentration of carbon dioxide in the air reached heights unseen for eons, the oceans absorbed the gas, and their chemistry shifted toward acidity. The very minerals the corals needed to construct their homes were being stripped away. Imagine the slow, silent crumbling of a reef, the once bright structures turning to gray rubble, leaving the creatures that relied on them without shelter or hope. Among the rubble lay the last of the trilobites, those ancient, armored wanderers whose lineage finally reached its silent end. This chemical betrayal extended far beyond the reefs. As the global temperature climbed by more than 11 degrees, the great currents that circulated oxygen and nutrients began to stall. The ocean became a stagnant pool, a warm and suffocating expanse where the deep, cold waters no longer rose to refresh the shallows. In this stillness, a haunting transformation occurred. The water lost its crystalline blue, turning a murky, bruised shade of purple as specialized bacteria thrived in the oxygen-starved depths. These microbes did more than just change the color of the sea. They began to exhale a toxic breath. Hydrogen sulfide gas, with its heavy, cloying scent of rotten eggs, started to bubble up from the abyss. It was an invisible poison that rose through the waves, drifting into the atmosphere and coating the coastlines in a lethal, invisible fog. On the land, the sun beat down through a haze of orange and yellow volcanic ash. The forests of the supercontinent Pangaea were withering, their deep roots finding only dry, salt-caked earth. This was the moment of the great thinning for the terrestrial vertebrates. Think of the Gorgonopsians, the saber-toothed titans of their time. These formidable predators, with their powerful jaws and fleet-footed grace, had dominated the landscape for millions of years. Now they were shadows of their former selves, wandering through heat-shimmered plains in search of water that had long since turned to dust. 7 out of every 10 species of land animals were disappearing. The pelycosaurs and the massive, rhino-sized dinosphallians were among the first to succumb, their heavy bones left to bleach under a sun that offered no mercy. The world was becoming a vast, empty gallery of what used to be. The numbers of this loss are difficult to hold in the mind. 90% of all marine species were simply erased from the book of life. 9 out of every 10 lineages that had swam, drifted, or crawled through the Permian seas were gone forever. In the water, the loss was so complete that it almost reset the biological clock of the planet. On land, 70% of the vertebrates vanished, along with nearly all the lush forests and a vast majority of the insect life. This was the only mass extinction in history to truly break the resilience of the insects, those persistent survivors. The sound of the world changed. The buzzing of giant dragonflies and the calls of early reptiles were replaced by the hollow whistle of the wind and the crackle of dry, dying ferns. As we reflect on this profound silence, we must realize that the Great Vanishing was more than just a list of names and dates. It was the closing of a door. The biological wealth of the Paleozoic era was being spent until the cupboard was nearly bare. Only a few lucky or exceptionally hardy survivors remained, huddled in the margins, waiting for a recovery that would take millions of years to arrive. The peak of the crisis was a time when the flame of life flickered so low that a single stray breeze might have extinguished it entirely. We sit here tonight, breathing an air that those ancient creatures could not, listening to a world that was born from their struggle. The void they left behind was vast, but in that emptiness, the first faint seeds of the world we know today were waiting for their chance to grow. The layers of rock are like the pages of an old, heavy ledger, stacked one on top of the other in a silent library that stretches across the continents. In a quiet quarry in Meishan, China, these pages are particularly thin, pressed tight by the weight of 251 million years. To the untrained eye, the stone is just limestone and shale, a dull sequence of grays and buffs. But to the forensic geologist, this is the crime scene of the ages. It is here that we find the ash, a fine, ghostly dust that settled over the world when the sky turned the color of a bruised plum. This ash is not merely debris. It is a timestamp, a record of the moment the pulse of the planet nearly stopped. As we examine these thin, dark bands, we are looking at the literal remains of the atmosphere as it was when the Great Dying began. The ash beds are soft compared to the surrounding stone, often no thicker than the width of a human finger. They represent a series of violent exhalations from deep within the earth, caught between the heavy limestone of the late Permian and the barren shales of the early Triassic. When you touch this ancient dust in the field, it feels curiously smooth, almost like flour, yet it carries the weight of 1 billion tragedies. Scientists sift through these layers with the patience of monks, looking for the microscopic signatures left behind by the Siberian traps. One of the most haunting clues they have uncovered is the presence of mercury. This heavy metal, this quicksilver element, does not belong in such high concentrations in a healthy ocean. Its presence in the Meishan sediments is like a chemical fingerprint, a toxic calling card delivered by the wind from thousands of miles away. Imagine the atmosphere during those final days of the Permian. The eruptions in the north were so massive that they did not just spill lava. They vaporized the very foundations of the earth, sending plumes of mercury gas into the stratosphere. This poison traveled across the globe, eventually raining down into the seas and settling into the mud. When we look at the mercury spikes in the rock today, we are seeing the literal fallout of a world on fire. It is a slow, methodical audit of a catastrophe. Each spike in the mercury levels tells us that the volcanoes had pulsed again, sending another wave of toxic stress through the food chain. It was a series of shocks, each one lasting more than 1,000 years, relentless and unforgiving, turning the oceans into a reservoir of heavy metals and sorrow. But mercury only tells us what happened. To find out when and for how long the suffering endured, we must look closer, down to the level of the zircon crystal. These crystals are the ultimate witnesses of deep time. They are tiny, no larger than a grain of sand, and harder than almost any other mineral. When a volcano erupts, these crystals form in the cooling magma, trapping atoms of uranium inside their rigid geometric lattice. From the moment they solidify, a tiny radioactive clock begins to tick. The uranium slowly, predictably, decays into lead. Because zircons are so durable, they are like armored vaults, protecting this internal clock from the heat and pressure of millions of years. They are the only things that survived the heat of the eruptions intact, carrying their secrets through the fire and into the cold stone of the present. In the laboratories of today, these zircons are extracted from the ash with surgical precision. They are washed in acid and heated in furnaces to clear away any modern contamination, leaving only the pure, ancient record. By measuring the ratio of uranium to lead within a single crystal, scientists can pinpoint its age with a staggering degree of accuracy. It was this forensic audit that revealed the true horror of the Great Dying. For a long time, we thought the extinction was a slow, dragging affair that lasted millions of years. But the zircons told a different story. They showed that the main pulse of the extinction happened with terrifying speed, occurring over a window of just 60,000 years. This was not a slow decline. It was a sudden, violent collapse of everything that had come before. 60,000 years may sound like an eternity in a human life, but in the grand theater of geology, it is nothing more than a sudden, sharp intake of breath. To lose 95% of all life in such a short span is almost incomprehensible. It means that the world we see in the fossil record, the lush forests of seed ferns and the sprawling reefs of glass sponges, did not just fade away. They were erased in a geological instant. The ash beds of Machen are the physical remains of that erasure. They are the dust of a burned world, settled at the bottom of a poisoned sea, waiting for us to learn how to read their silent, silver testimony. As we stand in that quiet quarry, the wind rustling the nearby grass, we are standing on the very moment the world almost ended, written in a layer of ash no thicker than a shadow. The world after the great dying was a quiet place, wrapped in a heavy, suffocating blanket of silence. If you were to stand upon the scorched plains of Pangaea 252 million years ago, you would feel a heat that does not simply warm the skin, but weighs upon the lungs. The air, thick with the invisible burden of carbon dioxide and the pungent, stinging scent of sulfur, moved sluggishly through valleys of gray ash. Most of the giants had fallen. The predators that once stalked the fern forests were gone, their bones already beginning to dissolve in the acidic rains that wept from a bruised, purple sky. In this vast, empty theater, one might think that life had finally met its match. But beneath the crust of the earth, in the cool, dark sanctuary of the soil, a heart was still beating. It was a rhythmic, steady pulse, belonging to a creature that shouldn't have been there, yet somehow, it was the only one left to answer the call of the dawn. This survivor was the Lystrosaurus, a name that translates to shovel lizard, though it was less of a lizard and more of a distant, ancient cousin to our own mammalian lineage. Picture a creature about the size of a well-fed pig or a stout dog, with a body that was barrel-chested and low to the ground. Its face was its most peculiar feature, a blunt, down-turned snout that ended in a sharp, horny beak, much like that of a modern turtle. From its upper jaw, two thick tusks curved downward, ivory white against the drab colors of the wasteland. These were not weapons for war, but tools for survival. We can almost hear the sound of those tusks now, a low, scraping rasp as the Lystrosaurus pushed through the parched earth, searching for the deep, moisture-rich roots and tubers that the sun could not reach. It moved with a semi-sprawling gait, a slow and deliberate waddle that carried it across a world where the very ground was a graveyard of its predecessors. The paradox of the Lystrosaurus lies in its simplicity. While the more specialized creatures, the kings of the Permian, collapsed because their narrow niches had vanished, this humble shovel face thrived. It was a generalist in an era of specialists. As the oxygen levels in the atmosphere plummeted, leaving other animals gasping and weak, the Lystrosaurus relied on its massive, barrel-shaped chest. Inside that ribcage was a pair of powerful lungs, capable of pulling life from even the thinnest, most toxic air. It was a biological design born for the underground, where oxygen is always a luxury. Because it was already adapted to the stale, stagnant air of its burrows, the global catastrophe was merely an extension of its daily life. It lived in the shadows of the earth, protected from the ultraviolet radiation and the searing winds, while the world above turned into an oven. It was safe in its earthen womb, listening to the muffled roar of a planet in turmoil. Think of the texture of that world. The plants that remained were tough and stringy, struggling to find nutrients in soil that had been stripped of its richness. The Lystrosaurus did not mind. Its powerful beak could crunch through the woodiest of stems, and its digestive system was a furnace that turned meager scraps into energy. It was the ultimate opportunist. In the millions of years that followed the extinction, this single genus began to dominate the landscape to a degree never seen before or since. Imagine walking for miles across a continent and seeing nothing but these pig-sized wanderers. In some fossil beds, they make up 95% of all land vertebrates. For a brief, strange moment in history, the Earth belonged to them. They were the world's only witnesses to the slow, painful recovery of the biosphere. They crossed mountain ranges that were still forming and waded through rivers that ran red with iron and silt, their footprints the only markings on a landscape of dust and bone. But survival at the end of the world came with a cost. The Lystrosaurus changed its very life history to stay ahead of the shadows. Evidence hidden in the rings of their fossilized bones tells us that they stopped living long, leisurely lives. Before the extinction, they might have lived for more than a decade, growing slowly and reaching maturity with patience. But in the unpredictable heat of the early Triassic, they shifted their strategy. They began to grow at an incredible rate, reaching sexual maturity in just a few years and dying young. It was a desperate, beautiful race against time. Live fast, breed early, and ensure that the next generation was already in the burrow before the parent succumbed to the harshness of the new world. They were the original disaster taxon, a lineage that bloomed in the ruins, proving that sometimes the race does not go to the swift or the strong, but to those who can hold their breath and keep digging. As we watch the Lystrosaurus move through the hazy twilight of the Triassic dawn, we see more than just a survivor. We see a bridge. It was a link between the ancient world of the Permian and the dawn of the dinosaurs. Without its stubborn refusal to vanish, the story of life would have taken a far different path. It carried the flame of our own distant ancestors through the darkest corridor of time. The paradox of its survival is a reminder of the resilience that lies within the small and the overlooked. In the face of a sky that had turned to fire and oceans that had turned to acid, the Lystrosaurus simply closed its eyes, retreated to its burrow, and waited. It waited for the dust to settle, for the rains to clear, and for the first green shoots of a new era to pierce the ash. It is the quiet champion of the great dying, a reminder that even when 90% of life vanishes, the heart of the world continues to beat, one slow, determined scrape of a tusk at a time. As we watch the Lystrosaurus move through the hazy twilight of the Triassic dawn, we see more than just a survivor. We see a bridge. It was a link between a world that had vanished and a future that was struggling to begin. To truly understand why that bridge was so narrow, we must turn our gaze back into the cold, silent layers of the earth. We must look at the rocks that remember the precise moment the world began to unravel. Imagine a geologist standing in a quiet laboratory, holding a small cylinder of stone. This stone is a witness. It is a record of 252 million years ago, layered with the dust of an apocalypse. Within it, there is a chemical ghost, a sudden, violent shift in carbon isotopes that serves as a fingerprint for the greatest crime in planetary history. To trace the culprit, scientists look at the subtle weight of atoms. They measure the relationship between carbon-12 and carbon-13, two versions of the same element that exist in a delicate balance within our atmosphere and oceans. At the end of the Permian period, the record shows a staggering drop, a negative excursion so sharp it suggests a massive injection of light carbon-12 into the global system. This was not the work of a few volcanoes. It was as if the Earth had suddenly exhaled a deep, toxic breath that changed the very chemistry of the air. For decades, the debate raged. Was it simply the lava from the Siberian traps, or was something even more sinister? The amount of carbon needed to explain such a shift was far greater than what could be produced by simple volcanic eruptions. The search led us beneath the ancient soil. The Siberian traps were not merely a collection of erupting mountains. They were a vast, subterranean plumbing system of fire. As the magma rose, it did not just pour out onto the surface. It forced its way through thick, ancient deposits of coal and oil-rich shale. Imagine the heat of 1,000 suns meeting the buried carbon of 100 million years. The resulting combustion was like a planetary engine of destruction. It cooked the Earth from the inside out, venting methane and carbon dioxide into the atmosphere on a scale that defies easy calculation. We are talking about thousands of gigatons of gas, a slow, heavy shroud that began to wrap around the globe, trapping the sun's warmth and refusing to let it go. The rocks in Siberia bear the scars of this intense heat, showing where coal was literally vaporized. Even the burning coal might not have been enough to cause the full extent of the isotope shift. Scientists began to look at even smaller actors in this tragedy, the microscopic life of the oceans. There is a fascinating theory involving a tiny microbe called Methanos arsina. Around the time of the Great Dying, it is believed they underwent a sudden evolution that made them hyperproductive. But they needed a catalyst to flourish, a specific nutrient that was usually scarce. That nutrient was nickel. And where did the nickel come from? It was spewed out by the Siberian traps, carried on the winds until it fertilized the seas. This triggered a microbial bloom so massive it turned the oceans into a giant, bubbling source of methane, further poisoning the atmosphere and the ancient sky. As the world warmed, a second, even more terrifying mechanism was likely triggered beneath the waves. On the dark, cold floor of the deep ocean, there are deposits of methane clathrates, methane gas trapped inside cages of ice. These are stable only as long as the water remains cold. But as the carbon dioxide from the volcanoes and the coal fires began to raise the global temperature by 5, then 10, and eventually 15 degrees Celsius, the oceans began to soak up that heat. The deep waters warmed. The ice cages began to melt. This released plumes of methane that rose like silent ghosts from the abyss. Methane is many times more potent as a greenhouse gas than carbon dioxide, and its release created a runaway effect, a positive feedback loop where warming caused more methane release, which in turn caused even more intense warming. The Earth was caught in a cycle of heat from which there was no escape. It was a greenhouse runaway, a planetary fever that reached nearly 40 degrees Celsius in the tropical seas, hot enough to kill most complex life directly. The scientific debate continues, with some arguing for the volcanoes and others for the microbes or the melting seafloor. But the truth likely lies in the synergy of all three. It was a perfect storm of chemical and biological triggers that pushed the world beyond its breaking point. As we reflect on these ancient isotopes, we realize how fragile the balance of our atmosphere truly is. The planet is a complex, interconnected machine. Tonight, as you rest, imagine the deep, quiet layers of stone beneath you, holding these secrets in their cold, silent embrace. The Earth did not die in a day. It was a slow, agonizing surrender that stretched across hundreds of thousands of years. As we look back through deep time, we see the Permian extinction not as a single event, but as a sequence of cascading failures. Imagine the silence that must have fallen over the supercontinent of Pangaea. The winds, once carrying the calls of strange creatures and the rustle of giant ferns, became heavy with the scent of sulfur. We find the evidence today in a thin, dark line of stone, a literal horizon of death that separates two worlds. When you run your fingers along that ancient rock, you are touching the moment when life almost ended. It is cold now, but back then the world was a furnace. The sequence began in the north, in what we call the Siberian traps. The ground did not just crack, it opened like 1,000 wounds. For nearly 2 million years, massive volumes of molten basalt poured onto the surface, covering an area larger than the modern United States. This was not a typical volcanic eruption. It was a relentless, pulsating flood of fire. The heat was so intense that it ignited vast underground deposits of coal, sending plumes of carbon into the stratosphere. The atmosphere became a thick, suffocating blanket. The sun became a dim, copper-colored disk, obscured by a haze that never quite settled. You can almost feel the vibration of the earth in that era, a low, constant rumble that signaled the beginning of the end. As the carbon dioxide levels soared, the planet's temperature rose with a terrifying momentum. The greenhouse effect, once a gentle regulator of life, became a trap. In the mid-latitudes, the heat reached levels that the modern mind can barely fathom, over 40 degrees Celsius in the shade, though shade was becoming a luxury of the past. The soil baked until it cracked into deep fissures. The rain, when it finally fell, was not a reprieve. It was a caustic, acidic downpour that stripped the leaves from trees and poisoned the freshwater streams. The forests, the lungs of the world, began to wither and die, their rotting remains feeding a cycle of decay that only added more gas to the burning sky. It was a world of orange horizons. Then the oceans began to fail. The water, warmed by the heavy air, could no longer hold the oxygen necessary for life. The currents slowed, and then they stopped. Without movement, the deep waters became stagnant and toxic. A group of bacteria that thrives in oxygen-starved environments began to bloom, turning the vast blue oceans into a murky emerald green. These organisms released hydrogen sulfide, a gas that smells of sulfur, into the air. For the creatures living along the coastlines, the air they breathed became a poison. In the depths, the coral reefs dissolved, and the trilobites, those ancient survivors, vanished forever. 96% of marine species were erased, leaving behind a silent, dark abyss where the heartbeat of the ocean had been so strong. On land, the story was just as bleak. The loss of plants meant the loss of herbivores, which in turn meant the loss of predators that hunted them. It was a collapse of the web of existence. Scientists estimate that 70% of terrestrial vertebrates disappeared. The diversity of life that had taken hundreds of millions of years to build was stripped away in a geological heartbeat. We see the verdict in the sudden absence of fossils. One layer of stone is teeming with life, tracks, shells, and bones, and the next layer is nearly empty, populated only by fungi and hardy survivors. It is the greatest crime scene in history, and the culprit was the Earth itself, reacting to a chain of events it could not stop. This was the Great Dying. It was a period where the delicate balance between the earth, the sea, and the sky was shattered. Yet, even in this absolute devastation, there is a profound mystery. Life did not vanish entirely. A few small, resilient lineages managed to huddle in the shadows of this global furnace. They endured the heat, the acid, and the poison. From these few survivors, the entire world we know today would eventually grow. The verdict of time is not just one of destruction, but of an incredible, stubborn persistence. The Earth took 10 million years to recover its diversity, but it did recover. The scars remain in the rock, a quiet reminder of how close we once came to a silent world. It is a story of ends and beginnings truly. The case rests now. Let the details fade. You are safe. Close your eyes, breathe deeply, and have a good night. Sleep well always. The silence that followed the Great Dying was not the peaceful quiet of a sleeping forest. It was a heavy, suffocating stillness that stretched across the continents for thousands of miles. Imagine a world where the air is thick with the scent of sulfur and ash, where the sky is a bruised shade of violet and copper. There were no insects to hum in the heat, no birds to call to one another across the valleys, and no rustle of leaves in a wind that carried only the dust of a broken world. The earth was a hollowed-out shell, resting in the wake of a catastrophe so absolute that it had nearly wiped the slate clean. We are standing on the edge of the early Triassic period, a time of profound emptiness, where the road back to a living planet would be measured not in years, but in millions of years of patient, agonizing survival. As the sun rose over the vast, barren expanse of Pangaea, it did not bring warmth, but a punishing, relentless heat. The temperatures in the tropics climbed to levels that would be unimaginable to us today, reaching more than 100 degrees Fahrenheit in the surface waters of the oceans and far higher on the scorched land. The atmosphere was a greenhouse trap, fueled by the staggering amounts of carbon dioxide that had been vomited from the Earth during the volcanic eruptions. This was a landscape of extremes, where the soil was baked into a hard, cracked crust, and the rains, when they finally came, were acidic and violent. Every morning, the horizon shimmered with heat waves that distorted the view of jagged, leafless mountains. The land was a skeleton, its ribcage of rock exposed to the elements, waiting for the first sign of a pulse to return to its dusty heart. Amidst this desolation, there was a small, persistent sound. It was the rhythmic scraping of claws against the dry earth. Beneath the surface, in the cool safety of underground burrows, lived a creature that would become the face of survival. This was Lystrosaurus, a sturdy, pig-sized animal with a beak like a parrot and 2 short tusks. In a world where 95% of species had vanished, Lystrosaurus found a way to endure. They were the lonely wanderers of the Triassic dawn, moving across the landscape in vast numbers because there was nothing left to compete with them. Imagine the sight of these resilient survivors, their breath huffing in the heavy air as they foraged for the few hardy ferns that managed to cling to life. They were the bridge between the old world and the new, carrying the spark of complex life through the darkest chapter of history. The oceans, once vibrant and teeming with trilobites and coral reefs, had become stagnant and ghost-like. For millions of years, the deep waters remained starved of oxygen, a condition known as anoxia that turned the seas into a soup of microbes. The colorful reefs were gone, replaced by thick, slimy mats of bacteria that thrived in the toxic, sulfur-rich environment. If you were to stand on the shore during this long recovery, you would see no crashing waves of blue, but a dull, pea-green expanse that smelled of rotten eggs. The recovery here was even slower than on land. The chemistry of the water had to heal, the acidity had to balance, and the heat had to dissipate before the first shy ancestors of modern fish and mollusks could begin to reclaim their ancestral homes. It was a silent, underwater struggle that lasted for 5 million years before the first true pulse of recovery was felt. For a long time, the Earth was a place without forests. This period is known to scientists as the coal gap, a stretch of 10 million years where no coal was formed because there were simply not enough trees to create it. The lush, towering swamps of the Permian had been replaced by a sparse, scrubby landscape dominated by mosses and small, hardy plants. Slowly, ever so slowly, the greenery began to crawl back. Ferns were the first to carpet the valleys, followed by the slow return of seed ferns and early conifers. You can almost feel the patience of the planet during this time, the way it meticulously rebuilt its ecosystems from the ground up. It was a slow-motion explosion of life, a green tide that eventually rose to cover the scars of the volcanic fires, providing the shade and the oxygen that would eventually allow the first dinosaurs to take their place in the sun. The road back from the edge of extinction was long and arduous, a testament to the sheer resilience of life on this small, blue planet. It teaches us that even when the world seems to have fallen into shadow, there is a persistence that remains, a tiny flame that refuses to be extinguished. The Permian extinction was a moment of near total darkness, but it was followed by a dawn that brought forth a world entirely different from the one that came before. We are the inheritors of that survival, the descendants of the few who found a way to breathe when the air was poison. As we look back across the 250 million years that separate us from that time, we can find a strange sort of peace in the knowledge that life, in all its fragile complexity, is remarkably difficult to kill. The investigation into this ancient mystery is now complete. The fires have cooled, the dust has settled, and the earth has healed. The story of the great dying is a reminder of the cycles of time and the enduring strength of the natural world. Let the images of those vast, ancient landscapes drift away now, replaced by the warmth and safety of your own surroundings. The case rests now. Let the details fade. You are safe. Close your eyes, breathe deeply, and have a good night. Sleep well.